Yeah, I think it's a very good explanation. I think you could also make an analogy using lasagna or something with layers.
I didn't think of that, but that's actually that's pretty solid. And my girlfriend is from a baker's family, so she will kill me if I say anything incorrect.
High risk.
Watch your words now.
There's nothing as permanent as a temporary solution, right?
Very, we recognize it. I can personally say to your girlfriend, you did a good job, so you don't get any trouble at home. Yeah, so welcome everyone. We are back with another episode of TechLab. This time we have Robin van Schaik with a very interesting topic we have not discussed yet before. But maybe Robin, maybe you would like to introduce yourself.
Yes, hello everyone. Thank you for having me, of course. Let's start off with that. I'm Robin van Schaik, 31 years old, live in Utrecht. And I came here for my studies to Utrecht. I did studies in economics and business economics. Something completely different than programming, I would say. In my spare time, I really enjoy the movies. So I keep track of what I watch on a platform called Letterboxd. Good luck finding me there. But if you do, you can see what kind of poor taste I have. But yeah, it's pretty nice. So I keep track of it, right? Apparently, I've watched almost 1,000 films, and there's a 1,400 still on my watch list.
Oh.
I don't think I will ever finish that. But it's pretty cool.
Nice. I hear a lot of similarities with you, Anthony.
Yeah, I'm also a movie addict, and the thing is, you can never keep up because they keep making more movies.
Yes.
So that's the thing.
Yeah, and honestly, also sounds a bit data engineering already, like having a huge list of films and having a long list to go yet.
The professional efficiency is clear, I think.
I think in theory you could build a recommender system, right? So I have to take out all the guesswork and just have something recommended to me, I guess, based on that input.
You already have a data set of 1,000 records, right?
Exactly.
You could solve a huge problem, though, because I'm always scrolling for 10 minutes through Netflix to find the correct one. This doesn't work. Yeah,
that does sound familiar.
Most of the time I just give up, right? So this is a problem my girlfriend and I face a lot. We just scroll through things and then we just give up.
Mm.
Yeah, but you could have a more scientific approach, right? Like what you're going to talk about today.
Yes, definitely. But in terms of movies, we have still a long way to go. In terms of how we do it at Bol, or at least in the team, we made a good start with that.
Okay, interesting to hear about it.
Yeah, I'm curious.
Yeah.
Sure.
So what was the problem that you guys were facing?
Yeah, let's give a bit of a context, right? First, before we dive into it. So I'm a data scientist, and I've been working at Bol for about 3 years now. First started off in a forecasting team, more on the commercial side, and around April 2023, there was the initiative to split off the team. So we did a lot of things for the logistics department and to really start up a new team. So basically, we gathered a bunch of people from different teams, also from other logistics teams and me, to create a new data science team, basically. So this is also focused on forecasting, but we serve 2 areas primarily. So one is on the warehousing side. So how many items do we expect to process in a given day? This is, of course, very important for Bol because we want to make sure that people get their items on time, but also that we do this in a cost-efficient way, of course. But then there's also the other side. So that's more about the carriers. So PostNL, but also Ampere. How many items can they expect? So that's through another proposition called VVB. Not sure if we touched upon that in the podcast before. Not yet.
So what is VVB?
Maybe a small...
a small sidestep. So that's short for Verzenden via Bol. So that's a Dutch acronym. So I guess shipping via Bol. So we also have other retailers on the platform and they can ship it themselves. So rather than sending the item to our warehouses, they can ship it themselves. So they can give it over to PostNL and they will hand over the delivery process from there onwards. So we work together with a team in the logistics department called capacity management, and they make sure that they communicate with third-party logistics services to make sure we have enough capacity at the warehouse, but also that PostNL knows what we expect to happen, right? And we are in this weekly cadence, basically. So capacity management makes a plan every week for 2-3 months ahead to basically say, okay, we expect X amount of items to be shipped on a given date. And this is a continuous process. So you can imagine, right, that it requires a lot of domain knowledge, and that's why the decision was made to sort of start a new team to make sure we're tight on the ball with our colleagues from capacity management. So that was a bit of the context, right? So we are a data science team. We have about 4 data scientists in the team, 1 software engineer, 2 business analysts, data analysts, and a product manager, I should say. And we sort of were grabbed together from different teams, and then you face a dilemma. So do you stick to the old ways of working that are very familiar to get up and running very quickly, or do you sort of take the time to rethink things, right? And I'm not sure if you guys heard of this joke before, but there's nothing as permanent as a temporary solution, right?
Very, we recognize it.
Right, so I think it felt as a natural moment to sort of rethink the process, right? Because you're basically tearing yourself alive. You say, okay, let's get this up and running, and we refactor everything down the line, and then things become so big. And there's always more pressing issues, right? Something's on fire, and we need to fix it right now. So basically, I really took it to say, okay, hey, let's rethink our process and make sure we have a solid foundation to build this team on. And we sort of stepped backwards, right? So we thought, okay, we want to make sure that our colleagues from capacity management have access to reliable output, and that starts with reliable data engineering. So we sort of took upon ourselves to really rethink the data engineering aspect of that. And I'm excited to share you about this journey, basically, to how we did that.
Yeah, that's really cool. Because it also sounds to me, indeed, what you mentioned, like this is probably the time that we should really rethink these things. So it also means you had a lot of issues with the flow you had in place.
Definitely. So, I mean, if everything was perfectly fine, right, and things went great, then there was no incentive for us to rethink this. But we had a number of issues, basically. So I'm going to talk about them more in depth later on. But for sure, there were issues, and it was sort of a continued struggle at some point, because we're in this weekly cadence. The planning cycle is very tight. We can barely afford any downtime, right? Or else you will create bottlenecks for the entire planning process, basically.
So how did you, because creating something new also takes a lot of time, right? And you're on a tight schedule. So how did you manage to introduce something new?
Basically, I would say it takes a bit of guts, right? It's hard to describe the value up front, basically. But I think we all felt the necessity for it. So to build this solid foundation. And the way that we described it was, we can go very fast right now, but we will become very slow towards a later stage. Or we can go a bit slower right now and then become very fast.
That's a good way to sell it. I'm
indeed.
gonna use this one as well.
But usually the people choose the
What is the quickest impact as soon as possible? I think that's the mindset. This is how do you say? This is quite a delicate trap to fall into, right? But given from our experiences on this tight operational cycle, you just know that, okay, more often than not, it's more about surviving, or it felt like surviving every week, because there were always different issues.
that this was not the way to go forward, right? So we had to rethink it and rather go a bit slower right now and go fast later on.
Mm-hmm. And because you mentioned that you really rethought this process, and it's also something that you were able to share across the other teams at Bull, because I feel like we have more data science teams, of course. Was it something they encountered as well?
Well, this is an interesting one. I think when we started out, we definitely saw us in the prime position to become an example. So we're part of a product team called capacity steering. And these are not unique issues, right? So we thought, okay, let's treat ourselves as a bit of guinea pigs and show how it's done. And then we can leverage that knowledge across our teams. And we actually see that already happening here and there, that we're sharing the knowledge that we've done, but also that other teams are becoming more aware of this, and they're sort of at times independently coming to the same conclusions that we did. So that's really cool. But yeah, still in the early phases there, but we definitely want to share more about this. And I think this is a good example of doing that, right?
Yeah.
Yeah, indeed. And it's also good that you can show the actual results of what you have done for people who are considering it, right?
Yeah, for sure. We got some examples to talk about for sure. They're mostly anecdotes, right? But yeah, I think they will speak volumes, because this is definitely an issue that people will encounter more often.
Mm-hmm. Yeah, you're building the tension here. I'm curious now.
Yeah, I was just thinking, when do we get to the good part?
Let's dive in.
Yeah, let's do it.
All right. Yeah, let's start off, right? So I briefly mentioned that we're a data science team. We're 4 data scientists, and I think that already shows you the first interesting aspect, I would say. So we own the entire process end to end. That means that we wrangle the data, we build our models to it, and we also productionize it. So I know that, for instance, in certain other companies, the data scientists built the model, they hand it over to a different department, and they productionize it. So it's more about the proof of value, the proof of concept, right? Rather than, okay, you own the process end to end. In our case, we own the process end to end, and that means that we need to manage everything. And I think this is already a nice segue to the first part, and that's you can imagine as things become more complex, it becomes more difficult to manage, and that's why we are using Apache Airflow for that. So to give you a brief introduction on Apache Airflow, because for me it's very familiar. I'm not sure if for you guys it's very familiar.
I know the name.
Yeah, it's on our tech radar, but what it actually is.
Yeah, I guess from the name you already know it's open source, right? It's Apache, it's open source. Cool. I can give you a brief history lesson, basically. So because there's a lot of similarities to the problems that we faced, right? So it was actually created at Airbnb in 2014 because they noticed that, okay, they had all these data pipelines, they were running cron jobs, so basically on a fixed time schedule, and they found it was increasingly difficult to manage that, right? So they had troubles figuring out why certain data pipelines were running late and how to debug that. And basically they created this workflow orchestration tool. This sounds very abstract, I can imagine. Mm-hmm. But I can provide you a more simple example of that. When we explain this to non-technical people or my mom or dad, I usually make the analogy of baking bread. And my girlfriend is from a baker's family, so she will kill me if I say anything incorrect.
High risk.
Watch your words now.
Yeah, exactly. But let's say we need to bake bread, right? And we need to do this at 9 o'clock every day. And when you're baking bread, there's a couple of steps that you take in a sort of a fixed order, basically. So, for instance, you combine some flour and oil and yeast and water. You knead it. You let it rest and proof. But in the meantime, you're also preheating the oven, right? And then once the oven is preheated, you put the bread in there. You wait a fixed time, take the bread out, you got bread, right? And it turns out this is very similar to data pipelines. So, for instance, we often combine sources, right? We re-aggregate them, for instance, from hourly level to daily level, calculate all kinds of metrics, and you already start to see the similarities with baking bread, but also in data pipelines that there's a fixed order of steps, right? That we need to repeat every day in our context. And if we were running everything on cron jobs and, I don't know, data was coming in late, then basically the whole step of the pipelines would be invalid, right? You would be working with stale data or no data at all. It would break down. It doesn't make sense. So in the context of baking bread, it's like you gathered all the ingredients and turns out the oven is broken. So why put bread in a cold oven? I hope that makes sense, but...
Yep.
It's important that it makes sense to your girlfriend.
Yes.
Else you have to sleep on the couch tonight.
Yeah, or I'd need to follow a workshop to bake bread or something.
Worst case, yeah.
Yeah, but yeah, so you see that's actually where Airbnb created this, but also for us, yeah, we're working with a lot of different sources of data. We need to combine them, and we need to make sure that it's reliably there every day, basically, because yeah, the planning cycle happens once a week, but we also need to gather new inputs on a daily basis, basically. And basically this, I'm going to introduce some terminology now. So basically this recipe is called a DAG, Directed Acyclic Graph, and basically means, hey, you take a number of steps, but you can't go back. It's not a cycle, it's a one-way flow. You can't unmix the ingredients that you needed together, right? You can't go back to raw flour. And every step in this recipe is called a task, and it's also a task in Airflow. And I think that sort of gets us to the terminology of where we want to move next.
Yeah, and does it also mean that whenever indeed you're at a step 4, so we've mixed all ingredients and the oven doesn't work, that, well, in data terms, you will throw away the full computation and start over again?
It depends. I guess we would touch upon a bit later more in detail, but basically that's where a lot of the issues happened for us, right? So we saw in the past that we tried to combine a lot of things at the same time. So we would write our scripts, right, or SQL queries, and we'd do the joining of the data, the aggregation, the calculation of the metrics in one go, because yeah, it's easy to get up and running, right? But in case there were issues, you sort of had to untangle everything. You had to step through the individual steps in your code again, and that got super frustrating for sure.
Yeah.
So yeah, you would have this mixture of flour, incorrect flour, I guess. You just had to throw everything out and just see where it went wrong, basically.
Yep.
Are you also getting hungry with this
bread? Honestly, yeah.
Talking about bread.
Yeah, maybe tomorrow morning I'll get some nice sourdough.
Yeah.
That's what I was inspired by out of nowhere.
After all his story.
Yeah, I'm just seeing pastries in front of me now.
Yeah. No. But I think it was a very clear explanation, right? I think.
Yeah, I really like the analogy.
Yeah. I do understand.
Yeah,
that's cool.
So what was next?
Yeah, to come back to it, right? So we felt very comfortable in the tech stack. We inherited Airflow from our old jobs, our old teams, and we saw at least that we were in a good place there. But it was more about how we utilized it. There was a lot to be gained there. And we did our research. I did my research, and we came across this article by Joel Schwartzman. That's called The Importance of Layered Thinking in Data Engineering. And to me, that was when things started to click, really. It was like a watershed moment for us. I can go a bit more in detail what this article is about. So basically, Joel talks about that they made this distinction in 7 layers. And they believe that if you separate your processing steps across these 7 layers, you can build more robust data science projects, basically. So this was also an issue they faced at Quantum Black, a consulting firm. And yeah, they basically saw a lot of the same issues that, okay, people hopped from project to project and the structure was completely different. People were re-engineering things, well, when they already should have been done, right? And they restructured it across 7 layers. I can briefly touch upon the 7 layers, but I'm not sure if this will get boring really quickly. But
No, I think as long as it like makes sense in the project that you guys did, then it's a really cool topic.
yeah, sure. So basically, they talk about this toy example of building a machine learning model that predicts when a machine has failures, basically, like an industrial machine.
Mm-hmm.
And the classic example is they have some inputs that are delivered through a CSV file. Well, unfortunately, this is still the case for us as well sometimes, right? Some inputs are still through CSVs. And what was really interesting to me is that they mention, look, files like CSVs, you want to be immutable, basically. This is your starting point of the entire process. You don't want to touch the original, basically. You want to be able to replay everything and get going again. So that's what they call the raw layer. So this is not always there, but if you're dealing with CSVs or Excel files or whatever, this is a good starting point. And then they would separate it out and say, okay, but you need to clean these CSV files a little bit. So perhaps you need to type them, make sure that some things are encoded as integers rather than strings, or you clean up column names a little bit. But yeah, the main point is, if you work with CSV files or something like that, you want them immutable, take another step to clean them up a little bit. So this happens not a lot, but we have certain processes as well that rely on such files. And then basically that cleaning up step, they call it the intermediate layer. So this does not happen a lot. And then you basically get to the bread and butter of the data engineering, right? So they mentioned that they call this the primary layer. This is basically the workbench where you transform your inputs and create inputs for your machine learning models. So for instance, we work with raw shipment details, right? Like the shipment labels, and we need to aggregate them to daily level, for instance. Well, you can go through a number of steps, for instance, by joining different sources together, aggregating them, and then calculating metrics on them. So taking the sum of something, for instance.
Mm-hmm.
So basically, this already conceptualizes, this is the bread and butter, this is where you want to group certain operations. And what was really interesting afterwards for us was the next step is what they call a feature store. So this is not a feature as in a website, like functionality, but in the context of machine learning, a feature is basically an input for a model, a variable, basically. So, and the feature store is basically a collection of all these types of inputs that can be picked and combined at will. And this solves a big issue for us. So we used to work on a per project basis where teams would re-engineer the same things all over again for project A and for project B. I got a clear example for that. So we built forecasting models, right? And one thing that we always touch upon is working with dates. You can't just use a date string, but you want to extract generalizable information from, right? So for instance, it's September 12th. It's a certain day of the week. It's the month September. It's the year 2024. This is information that you can use and basically teach your model to, okay, there's a certain pattern on the Fridays. There's a certain pattern on September. There's a certain year-over-year trend. Mm-hmm. And much, much more, right? Like it's the week for Christmas or whatever. So we do this a lot. And we saw that this was a process that always gets repeated across different projects. And basically, definitions were inconsistent. People would re-engineer them in different ways. It would become very redundant at some point. And that's what I really liked about the article, because this really touched upon the core for us. That, okay, let's just collect everything that we do in one central place, And then as soon as we start building our models, we can just pull the relevant information from there. And that's just great. I'm just going to talk a bit more about the layers next, but afterwards we can touch a bit more about the feature store and why we think it's great.
Mm-hmm.
And then they conceptualize it as, okay, there's this model layer. So basically all the model logic where you actually combine the things, right? So we basically pull in the different features, you combine into one data set for training your model on and evaluating your model on to see how well it performs. And that's basically another layer in the process. Of course, these models generate output, so that's what they call the model output layer. These models generate predictions, but also there's like model artifacts, which is basically the file to run everything on. And finally, there's a reporting layer. And this was also very neat for us, where basically you will prepare things for dashboarding or generate a data set where you will compare the actuals with the predictions and evaluate the models on. Basically, the whole takeaway from us was, okay, there's this logical ordering of things, and this makes sure that we are not creating very large DAGs, so it becomes impossible to follow, but there's more of a logical ordering to things.
Yeah, I think this is a very good explanation. I think you could also make an analogy using a lasagna or something with the layers.
I didn't think of that, but it's actually it's pretty solid to, with the bread example.
Yeah, exactly.
Yeah.
So once I got hungry, it's all about food, but try to ignore that. No, so what would you say are the advantages, all the advantages of using the layered approach?
Yeah, so I think one I briefly touched upon was we first would redo all the data engineering on a per project basis. So this also meant that we would sort of get siloed into thinking on a per project basis, right? But we're working on things as a team. So we had different pipelines running for the projects, and people would just look at their own pipelines and things. So I would say, one, it makes sure that we have a shared ownership of things. So people can jump in and maintain them, and there's this sort of logical ordering to things. But second, it makes sure that there's better discoverability of what is done. So we're not repeating things because they're just hitting away, but also it's very clear. You just see in the DAG what are the steps being taken. Another one, and in particular the feature store one that I mentioned that we really like, is the iteration speed for us really increased. So if we just want to experiment with a new model, right? For instance, we want to add a new feature that's about the week for Christmas, we can just pull it in. So that's just great. We would just re-engineer the features beforehand. And if we have a certain hypothesis that, okay, we believe that we can do better on the week before Christmas by feeding it additional information, let's just pull it in. So a lot of the work has already been done for you. You just need to combine it when you're building the model and not go into the code base to add it again. But what's also great for us is that we took the extra effort to engineer them in different ways. This might seem a bit abstract, but for instance, certain libraries or certain types of models, they can accept string values. So like Monday, Tuesday, Wednesday, whatever. But others, they require more of like a binary encoding. So Monday as a 1 if it was a Monday, or Tuesday as a 1 when it was a Tuesday, etc. So also, it's not about just adding features, but also switching between model types becomes very trivial for us, right? The rest of the pipeline of training a model is sort of similar. So that's great. And finally, where one of the big headaches that we face constantly was, the dreaded, the output looks off. You get informed by stakeholders that they're not happy with the output. Something looks off. What caused this? If all the data processing logic is within the model, that means you need to step through it with a debugger, go through it line by line, see how things were transformed, and infer from that what went wrong. Whereas if you just take that process out of it, we have then a nice BigQuery table you can actually observe what went in, right? It's quite easy. You just look at the table and you can say, oh, at this point in time, it was this value. We can see that this was weird.
Yep.
Yeah, I'm sold. I think it's a good story to go for it, right?
Yeah, no, for real. Like I once was at it's a bit of a sidestep, but I once was at a meetup, I think, from Mali, if I'm correct, and there they also talked a lot about data engineering, the pipelines that they're running there, and especially on the fraud protection side, because of course for credit cards, it's a really big rabbit hole you can dive into, and there they really touched upon like being a data engineer and trying. Maybe I'm saying stupid buzzwords now because I'm not a data engineer, but I think it's you call it you build features on a model, right? So it could be that you build a certain feature and that the model doesn't improve at all.
Yeah.
And they really talked about like what that does to like engineering teams sometimes and what the meaning behind it is. I'm just really curious. Like, does it happen quite often as a data engineer that you spend a couple weeks, months on research and it doesn't turn out with an uplift?
Well, this is interesting. So for sure, right? So especially on the data science side, we're almost like a mad professor that we experiment and look at it and see, okay, this causes a positive uplift, this works or not. And in case it didn't work, we would often discard all that effort, right? But this may only be the case for one particular project and not for the other. So by just centralizing it and, okay, if they're engineered properly, then can add some sort of value in the future, maybe in combination with other things. So we are very conscious about that fact, and we just make sure we keep things around much longer before we start discarding them, because it can add value in the future. And also prevent some sort of redundant work, right? So, I have this idea 2 years later, maybe we can do this, and it turns out we already engineered that feature. We don't need to do it again.
Yeah. Is that some sort of research bank that you're saving up, or is it more of we have some sort of library where we put this stuff still into?
Well, we try to document things as well, what we tried. So we run things in something called the Jupyter Notebook. So basically, this is more of like an interactive code environment where you can mix Markdown with code. So, for instance, we use Python, right, to run things. So, for instance, we have a branch where we say, okay, we add feature A to it. We run it on our evaluation data set and see that whether it improves or not, basically. And we document that for sure. So, okay, we see that based on this evaluation data set, it has a positive effect or a negative effect. So that's more about the library aspect, right? About what the effects are. But I would say that also for future efforts, we store them. Luckily enough, we often work with quite some aggregated data. We're not always on the SKU level. So the storage costs are not immense, right? We're not hoarding data just because we can, but it can be helpful down the line for sure.
Yeah. Awesome.
Yeah, interesting. So next to the layered approach, are there any other things you investigated to make things better?
Yes. I briefly touched upon this, where you get the dreaded message, oh, the output looks off, we need to debug it, right? So this can happen, of course, in the modeling code, but also in any of the steps beforehand, where you're just pre-processing the data. And what we saw there is that people would take shortcuts, basically. So, for instance, if you need to create a data set, they would, join two data sets together, aggregate them, recreate some metrics there, and would do it all in one step. And as a result, you usually get massive queries or large chunks of Python code, but they would still be executed as one task in your Airflow DAG, right? It's in your recipe. And this was a big hassle. So every time we had issues, we sort of need to rip open the guts, run steps manually, and then debug that. So we call this process multitasking. You're basically doing multiple things in one task. And we made a conscious decision to go towards monotasking. And I will explain that in a little bit. So basically, we have the principle that within the task in Airflow, you have one purpose. So one purpose is joining two data sets together, or aggregating the data again, or calculating the metrics. And first of all, it gives us much more clarity in what's happening. There's a logical ordering, like talking about the bread. Like, okay, you knead it together, or you just let it proof for a bit, or you preheat. It becomes very clear what's happening. So in terms of just looking at it from a glance, you can already see what's happening rather than having to dig through the code and just see, okay, there's some issues there. But on the other hand, it also gives us opportunity to separate things out. So in software engineering, this is called separation of concerns, right? Yeah, this is something we're not always good at, but we looked at it and started to apply that. So if you start to break things in logical steps, in small steps, you can test things. You can test individual steps. So you can create unit tests, of course, but also data quality checks, basically. I'm going to make another side step here. So basically, during our research, we came across this workflow that was employed at Netflix called Write, Audit, Publish. And basically, you would execute your code, write the output to like a staging table or a bucket or a separate table, but that's not part of the production environment, basically. And then you would apply automated checks, the audit step, basically. So you can imagine if you're joining two tables together, you expect that there will be no duplicates in there, or that there will be no nulls as a result of a join.
Would be nice.
That would be nice, right? Unfortunately, it happens that things are not always correct because there are things happening upstream by other data producers that they missed or something. And you want to catch that as early as possible. So because we're now implementing monotasking, we can just test every step in the process. So whether the join fails or whatever. So this gives us a lot more trust in the systems that we're building, so we can catch on errors quite early and whenever they happen. But it also helps us in resolving these issues, right? So rather than saying the end result being off, we see that the join was off. And this already gives us an indication where to start digging and how to resolve the issue. So for us, this monotasking really helped us into building more reliable pipelines. And of course, we can always do a better job at it and add more tests. But this is definitely a step in the right direction for us.
Yeah. And as a rookie, I just have a follow-up question. So, like, indeed, going back to the analogy of the baking bread, what if step 3 fails in this what was it again?
Monotasking.
Yeah, would it be able to, you see the error, you fix the error, and then from step 3 onwards, you will continue?
Yes, so, that's the beauty of it, actually. So we also made a conscious decision to store all the intermediate steps in BigQuery tables or in Parquet files in Google Cloud Storage buckets. So we can continue from that onwards. And I can imagine there's a certain trade-off there, right? There's a lot more data being persistent. There's some storage costs that you incur there. But for us, this trade-off is definitely worth it because we can resolve issues much, much faster that way. But you're definitely right. You can just continue with the next step, basically, as if everything was all right.
Promising.
Yeah, interesting. So you said this looked like a separation of concerns from traditional software engineering. So do you interact a lot with the traditional software engineers to maybe learn things of what they've been doing?
This is great. So we have one software engineer in the team, Jean, and he came from a very different background. So not from data science at all, not from data engineering, but also more of a full stack approach. We've been learning a lot from him because he has a certain way of looking at things, especially when, abstracting things or applying separation of concerns. And we've been learning a lot from him. So at first, our tech lead was really buzzing us about, okay, you need to include more unit tests or you need to add more tests. And this is not a workflow that we're really familiar with as a data scientist, right? You think, all right, if the data looks good, it looks good. But this is something we really learned. And also lately, when we made changes to the code, or when I made changes to the code, we had some unit tests set up, and you feel a lot more confident in making these changes because, okay, the logic holds true.
Yep.
Yeah. It sounds like there's a lot more to be learned from the software engineers.
For sure, yeah.
And the other way around. I really like I think still in Bol we have some teams, right, where it's like multidisciplinary and where you really show the. Do we still have the MLE role?
The machine learning engineer?
Yeah,
For sure. So other teams are more hardcore, I would say, right? They have a different requirements than us. So they probably, latency is a big thing because they need to serve recommender systems. Yeah, that's a completely different ballgame from us, where we run batch jobs once a day. It's more about building reliable data pipelines in terms of quality rather than reliability in terms of uptime or latency. But yeah, for sure, there's that role there. It's just a different ballgame, basically. And I can imagine there's different trade-offs there, right? That if you need to be very fast, maybe there's less time to break things up in steps, right? The latency is everything.
Yeah, so we talked a bit about the data. Huh? We talked a bit about the code. So you can guess where the next question is going to.
I'm really bad at guessing.
Yeah, same.
Okay,
I'm also
okay.
curious now.
So aligning the code and the data structure.
This is cool. This is cool. This was something we discovered by accident, basically. Also coming from frustration, basically. So we used to have our code base or our data processing, bit fragmented. So it was all in one repository, right? But if you wanted to add a new step in your DAG, you would basically need to add files in multiple locations. And sometimes this became very confusing, especially if you needed to refactor things, right? It became quite a hassle. So we had the idea to sort of mirror what's happening in the DAGs, right, to our code structure. So that means that our mono repo, so that's one big repo where we store all our data processing code, to mirror that. So we have a directory structure that's also in the layers. So we have a folder for the raw, intermediate, primary, etc. We keep the models in separate repositories because they get quite wieldy and they require their own logic. And we see that there's a number of benefits there. So first of all, each folder maps to a specific table that we create in our data processing pipelines. So it's quite easy to follow what's going on. But also because you have this visual interface in Airflow, like this flow chart, you can actually see, hey, if I make changes here, it's going to impact XYZ tables as well downstream. So it became almost like playing with bricks. I don't know another brand analogy for this, but let's keep it at Lego bricks. So if you want to add multiple steps there, you just add multiple folders there where you contain your schema, your data collection codes, all that jazz, basically.
You're having these glasses on constantly of checking how can we actually improve these steps. And I think that's super nice, in both in engineering, but especially as well in data engineering.
I think the nice part of this is it's not like it's an all or nothing deal, right? You can apply certain concepts depending on your situation, or you can apply them in small bits before you move on, right? So I can imagine, maybe it doesn't make sense to group things in the DAGs the way that we did if you're in a certain team or becomes too unwieldy, but you can mirror the code base towards the code structure, right? So I think that was the takeaway for us, that, okay, we're constantly learning about this and we're figuring out if this works or not. To be honest, I was super nervous when I proposed this and we just started building because, okay, what if I made a big mistake and the code base becomes completely unwieldy?
Mm-hmm.
It works out pretty nicely so far, but we're still learning.
Yep.
But it's not an all or nothing deal. That's basically what we're trying to say. We're just taking what we can and move on from there.
Yeah. For me, it also really looks, or it sounds a bit familiar with like whereas in software engineering terms, you have these SRE budgets where whenever you have a lot of time, maybe you will do maybe a bit more risky thingies. And then when you see, okay, the availability drops, we should maybe play it a bit more safe. And it also feels like here where you really should find a balance in between, okay, are we going to innovate? So that means we will probably, push still some legacy and we're going to create new features on it. Or we're really going to rethink it and get the investment later on. And I think that's a really cool and super cool process, though.
Yeah, indeed. And in this situation, it paid off, right? So.
Yeah, for sure. And this is something also we're trying to share across the different teams in capacity steering as well, because within the data science teams there, we have the same issues basically. We need to run a job at a certain point in time, and we need to make sure of reliable data in there. Yeah, whether you apply like concepts like monotasking or not, but we can add the quality checks in there for sure. Or whether we think that mirroring the code base to our data structure makes sense or not, sure. But there's a lot to be gained there. And I think this, we recently had issues as well where, some data producers produce some faulty data that, all right, let's make sure that we add quality checks as there as well. So not only on our side, but also at the producer side. I think if we keep doing this across Bol, then we have built a lot more robust data systems, basically.
Yeah, indeed. Yeah, I think this was a really nice
I agree. Yeah,
conversation. Good advice for other teams working in ways like this.
Yeah, I mean, getting better data and having nice bread, two things at once.
Yeah, indeed. Yeah. Eating and make things better. It's best of both worlds, right?
And the cool thing is, you're also writing this down for a blog, right? If I'm correct.
Yeah. So you can expect it soon on the TechLab blog, techlabbol.com.
I'm sure I missed a lot of details in there. That's probably covered in the blog, but I guess also vice versa, right? We talked a lot about different things there we didn't cover in the blog. So I think it's a nice companion piece for sure.
Definitely. And I can personally say to your girlfriend, you did a good job. So you don't get any trouble at home. And I also love the fact that your guys keep learning. So please come back when you have another set of learnings which you'd like to share.
Yeah, we're working with some cool things. We also have some other things that were the first within Bol in implying that. So I definitely would love to come back around to tell more about these experiences as well.
You're always welcome.
Yeah, lots to be learned about data. So thanks a lot, Robin.
Thanks for having me.